Go ahead and start doing this.
Yes.
All right, guys. Hopefully you got to know your partner a little bit better. Let's go ahead and jump in.
Did anybody not know that we had like
When? Oh,
I didn't know that.
Yeah, we have no
I found out
school.
this morning. I was like, what?
no school. Monday is Columbus Day.
I didn't know, and I got so excited. They're like, you know how you got saying, enjoy your long weekend.
All right, guys, I need you to refocus. Refocus up to the front. Before we can add and subtract rational expressions, let's go back to what you know about basic fractions. If you were adding 3/4 and 3/16, would the least common denominator, well, let me ask you, what would be the least common denominator between 4 and 16? 16. Now, if you didn't know that, here's one way to always determine. If you look at 16, it's 4 times 4. They both already share a 4. When you're trying to determine what's the least common denominator, you're essentially looking for what factors are missing. So I can see that there's a 4 here by itself. So I need another 4 over here. And then when I'm looking at what is the least common denominator, that's the smallest number that both denominators multiply into. So it is 4 times 4. It's 16. Okay, so hopefully your answer was no, which it was. There is a smaller common denominator than 64. What would it be? 16. And you picked this because 16 is the smallest number that both 4 and 16 would multiply into. When you are looking at expressions with variables, you're looking for the same thing. You're trying to identify what's the missing piece. And that's what you need to multiply the other fraction by. So let's go ahead right up here and let's mark that we were missing another 4. We're missing another 4. So we needed to multiply. Okay, now let's extend this to some expressions involving variables. I want you to skip that first one and move to this one right here. If I'm looking at this adding and subtracting fractions, I need a common denominator before I could add or subtract. The first thing I want to see is what do they all share? What do they all have in common? 2x minus 1. This is like saying there's a 4 here, and there's a 4 here, and there's a 4 here. I might, in fact, want to write it out. 2x minus 1 squared is really, let me go ahead and do that a little bit smaller. It's really 2x minus 1 times itself. This is really 2x minus 1 times itself, And this is just 2x minus 1 times itself. They all share 2x minus 1. I could see they share it here, they share it here, and they share it here. It's like saying they all share a factor of 4. So I'm not going to just multiply them all by each other. That would not create the least common denominator. I have to determine what is missing. And when you're looking at what's missing, go to the biggest denominator. Here I have 2x minus 1 times itself times itself. There's 3 of them. So obviously I only have 1 if I'm looking at the fraction to the right. How many additional 2x minus 1s do I need in order to create the same denominator? 2. So I would need to multiply this by 2x minus 1 squared over 2x minus 1 squared. If I look at the first fraction has 2 sets, or really just 2 of 2x minus 1. So how many additional 2x minus 1s do I need? 1. 2x minus 1 and 2x minus 1. Yes. Cute. Awesome. So if I was to ask you, what is the least common denominator in this situation? It would be 2x minus 1 cubed. I want to give you one more example like this one. So I'm adding like a part C. What if I give you 1 over x plus 1 plus 1 over quantity x plus 1 squared? What would you have to multiply the first fraction by? Good, x plus 1. Notice you didn't say x plus 1 squared because this one already shared. It already had an x plus 1.
Would like the 1 be on the outside of the parentheses?
The 1 you would be multiplying it by. So then you'd have to distribute it in.
Yeah, like 1 x plus 1.
Yes,
That-
but that would
yeah,
just be
I
x
was
plus 1.
just asking like. if
But
you-
yeah, you're not adding it.
So for 2, it'd be like 2 and then 2x.
Yes.
But
Well,
yeah,
you
that's what I
would
was asking.
distribute. So it'd be like 4x minus 2 when you
Yeah,
distribute.
I was just asking if it like went on the outside.
Yeah, awesome. And we're going to do that also, which is great to lead towards. Okay, so if I asked you what's the least common denominator of this one, you would have said x plus 1 squared. That's the smallest denominator that they would all multiply into. Now, if I go back to that first one that I skipped, this is x minus 1, and this is x plus 1 squared. Do they share anything? As far as a parentheses, do they share anything in parentheses? Let me ask it in this way. Do they share a factor? So this has x plus 1 times itself, right? And this one's x minus 1.
Well, it has
So,
to be 1 positive and 1 negative.
well, we have x plus 1, this one's x minus 1. Imagine if x was 6. What's 6 minus 1?
5.
5. What's 6 plus 1?
7.
Are 5 and 7 the same at all? No. So this, they don't actually share anything. So even if you just see a minus and a plus, that's not sharing in any way. If they don't share factors, then you basically multiply them by themselves. So I would have to multiply this one by x minus 1 over x minus 1, and this one by x plus 1 squared over x plus 1 squared. I'm going to be asking you a lot in this lesson, what is the least common denominator? And that's because in the next lesson, you have to identify a least common denominator. So I want to make sure we know what we're looking at. If I asked you, what is the least common denominator of this problem? What would it be?
Like
2x plus 1s.
Right, I want to be like 2 least common.
So the least common denominator, you are looking between two denominators, but you're seeing what's the same number that they multiply into. So looking back at this first fraction, what was the least common denominator? You needed another 4, right, to create the 16. So the least common denominator is what are you trying to obtain in each denominator? So if I was to ask you what's the least common denominator in this expression, times, exactly right. Nice. All right, let's move on to reviewing. How do you add and subtract basic fractions so that we can go ahead and start adding and subtracting some of the ones with variables? So if I was to ask you, add 3/4 plus 5/8, hopefully you know you need a common denominator. What's the least common denominator between 4 and 8? 8. Now you could have said that because 8 is really 4 times 2. And well, you could go down further, but you see that they share a 4. So we have to multiply the fraction by what's missing, which is 2 over 2. And so the least common denominator is really 2 times 4. It's 8. Okay, so we multiply that out, and 2 times 3 is 6. So I have 6/8 plus 5/8. What's 6 plus 5? 11. And then I keep the denominator, right, of 8. Okay, what if I give you something like this? So I'm going to say versus 6 over x plus 2 plus 5 over x plus 2. You should hopefully know how to add them based off of what we did. What would you do with the denominator? Well, if I was adding them, do they have a common denominator? Yeah. So you keep the denominator. Good. And what would you do with the numerators? Add them. Good. So it'd be 11 over x plus 2. These are more the type we're going to focus on today, but I want you to see how they're actually the same as what you've been doing with fractions. Okay, let's take a look at the next one. What's the least common denominator between 15 and 11? Olivia? Nice. It's 15 times 11. It's 165. They don't share anything. If they don't share any factors, then you just multiply them by each other. So I'm going to multiply this guy by 11 over 11, and this guy by 15 over 15. And then I'm going to simplify this out. 11 times 4 is 44 over 165 minus 7 times 15 is 105 over 165. What's 44 minus 105? 61, I believe, over 165. And that's it. All right, let's go ahead and start looking at some more examples. This one here is very similar to what you just did. Looking at this question, m minus 1 and m plus 1 are completely different. It's like you're looking at a denominator of 15 and 11. They're different. So what am I going to have to multiply this first fraction by? Good, m plus 1.
I was going to say when they like cancel out, but that's multiplication.
Yes, good. If this was a multiply, then they would cancel. Awesome. And then this one I'm going to multiply by what? Good, m minus 1 over m minus 1. Now, if you've done that process correctly, you should have the same denominators. So that's what I like to do first. I like to check my denominators. This first denominator would be m plus 1 times m minus 1. And this second denominator would be m plus 1 times m minus 1. Now, we know from all of our previous work, we have to add the numerators together. But this is going to take some simplifying. How do I multiply m plus 1 times m plus 1? It is m plus 1 squared, but I'm going to have to simplify that out. Good, and I'm going to have to use the process of FOIL. So if I FOIL that out, first times first gives me m squared. Outside gives me 1m. Inside gives me 1m. Last gives me 1. And then I need to combine the like terms. Which two are alike? Good, m and n. Yeah, so we got m squared plus 2m plus 1. Okay, in a similar fashion, you are going to have to FOIL out m minus 1 times m minus 1. So I'd like you to turn to your partner. And the person who has the most events going on this weekend, you sit back and relax. Have your partner tell you what this would FOIL out to be. Go ahead and turn.
Okay, so I already did it. So it would be m squared minus 2m plus 1.
Awesome. Okay, and I'll stop you there because that's really all I asked them to do. But I'm sure you already finished it. So,
M minus 1, M minus 1.
yes.
So that would be.
Everything's the same except nothing. But yeah. And then we're finishing it. Squared minus 2m. Good job.
All right, guys, let's check it. Did your partner FOIL this to be m squared minus 2m plus 1?
Yes.
Hopefully you did. All right, now that the denominators are the same, remember when adding two fractions, you keep the denominator, so m plus 1, m minus 1, and you combine the values in the numerator. So what is m squared plus m squared? 2m squared. What is 2m plus negative 2m? 0. And what is 1 plus 1? Positive 2.
Would you take out?
The only time that you really need to take out a GCF is if you're checking to see, is there a factor that cancels in the numerator and denominator? So if I'm checking here, m squared plus 1 is different than m plus 1. So there's nothing that can be reduced.
But that's still a development.
But yes, either of these are good answers. In fact, you might see one in the back of your book or another one. They're just valid. You know that a fraction is simplified when there's nothing left to reduce. All right. Any questions on that?
It sounds, you're quite good. I was gonna say it sounds bad, but can't you also simplify it m squared But you can't because it's addition.
Yes, if this was a minus sign, then we could technically reduce all of these.
Yeah, but you can't do that because there's no room for a sum of.
2 squares. Nice. Awesome. All right, good question or good thoughts. Any other questions before we move on? Okay, let's look at this next one. What is the least common denominator between 3p, 4p, and 2p? 12 is correct, and p. Notice they already share a p, so I don't need to multiply them all by themselves. What do I have to multiply this first fraction by? 4 over 4, good. 3 over 3, and 6 over 6, awesome. So I get 32 over 12p plus 15 over 12p plus 54 over 12p. And then I add them together. So 32 plus 15 is 47. 47 plus 54 is 101. So it'd be 101 over 12p. All right, last thing we're going to look at is subtracting 2 fractions. When you subtract 2 fractions, you do still need a common denominator, but to make your life easier and to make it all the way simplified, make sure your denominator is in factored form first. So with that said, let's see if we remember how to factor. Looking at this first fraction, in the denominator, the last term is negative. So am I going to have the same signs or different signs? Different. What times what gives me x squared? Good, x times x. And what times what would give me 2? 2 and 1. And I'd have a +2 and a -1. Okay, now turn to your partner and the person who has the most going on this weekend. If you could factor the second denominator. So, Olivia, I've got a lot of events going on. My mother-in-law's having a pool party too, which I don't know how you can have a pool party in the middle of October, but it seems like it's
Yeah,
okay.
it's raining right now over here, so.
I don't know how that's gonna work. We'll see. Okay, so the last term's positive, so we know we're gonna have the same signs, minus and minus. X times x would give me x squared. And if I try 2 and 2, that won't add up to be 5x, so it would be 4 and 1. Do you agree?
Yep, that seems about right.
Got it right. All right, guys, look up here. Did you get x minus 4 and x minus 1? Yes? Good? Okay, Caroline?
Sorry, I was gonna say, I think I know what you might.
All right. You might know that I'm going to say this, but what do they already both share? X minus 1.
So you multiply the first one by x minus 1.
Yes. If I'm looking at what is the first one missing, it's missing an x minus 4. So I have to multiply this by x minus 4 over x minus 4. What is the second fraction missing?
X plus 2.
Good, x plus 2 over x plus 2. Now, if you have identified those pieces correctly, you should have the same denominators now. So I like to check. The first denominator is, it's big. It's x minus 4 times x plus 2 times x minus 1. And I know that I'm subtracting the second fraction, but the second fraction is the same denominator. You can rearrange those parentheses because multiplication's commutative. So I'd have x minus 4 times x plus 2 times x minus 1. Now, more strategic work comes in. I have to simplify the numerators.
Say x plus 1.
Where? X plus 2, x minus 1. All right, now they're the same. So let's look at the numerator. What do I have to do with this x if I'm multiplying it by x minus 4? Distribute. So that would give me x squared minus 4x. And looking at the second fraction, I have to distribute the 2. So I have minus 2x plus 4. Okay, when I'm subtracting 2x plus 4, I have to be careful. 2x plus 4 has invisible parentheses around them. I might want to mark those in. Because when I'm subtracting them, I need to remember to distribute the negative or to subtract both terms. If I don't distribute that negative, then I will have the incorrect answer. So make sure you remember in minusing, you have to minus every term in the second fraction's numerator. Okay, but now all the denominators are the same, so I can go ahead and put them all over their common denominator. X minus 4, x plus 2, x minus 1. And I can distribute that negative. So that would give me, we have x squared minus 4x minus 2x minus 4. And then the last thing I can do is simplify. What's negative 4x plus negative 2x? Woo. Good, negative 6x. So I'd erase that, and that comes out to be negative 6x minus 4. If you could factor it, you would, which is always a good thing to check for, because if I could reduce any common factors, I would need to, but I can't factor it. Can you factor that? Don't think so, because it has to be plus minus. So nothing will add up to be 6. That's why we can't, because nothing can, yes, that trinomial is prime. All right, we did one together. Try this one on your own. I'm going to walk around if you need help. And you have a few minutes to try it. What?
That was
A lot of work there.
That's a lot of work. All right, let me see more. Let me see more. All right.
Hey guys, first thing I want to ask is, did you factor it down correctly? That's probably the most important step to being able to finish this well. Y squared minus 1 factors down into y minus 1 times y plus 1. Y squared minus 2y plus 1 factors down to y minus 1 times y minus 1. So check that. Did you get that correct? Now, the next piece that we would have to do is we have to obtain a common denominator. They both share y minus 1. So I'm really looking for what's missing. What do I have to multiply this first fraction by? Good, y minus 1. Now I have y minus 1 in both denominators. What do I have to multiply this fraction by? Good, y plus 1 over y plus 1. If you got that much correct, awesome. Now let's go ahead and keep simplifying. So we distribute the y. In this first fraction, we have y squared minus y over, I'm just going to call this y minus 1 squared, because that's what that comes out to be, times y plus 1. And then I have minus, I'm going to distribute the y here, y squared plus y over y minus 1 squared times y plus 1. This is tricky. What do I have to do with this negative? Nice, distribute. A lot of things will cancel. So if I start combining here, I'll get y squared minus y squared minus y all over y. And so, yeah, the y squareds will definitely cancel.
So just be negative.
Yes, if we're adding negative 1y plus negative 1y, that comes out to be negative 2y over, I was right, I can hear them, over quantity y minus 1 squared times y plus 1. And that would be it. What?
We got through that pretty fast.
We did get through that pretty fast. I heard, did you guys hear that? That bum, bum, bum.
No.
No, was that just me?
No.